Welcome to the Unit 7 test review on exponents. So page 1 here is going to be 7.1, where we're going to be simplifying algebraic expressions by applying the laws of exponents. So let's figure out these laws. So first we have multiplication of like bases. Let me make this a little smaller. So you have multiplication of like bases. What do you do to the exponents? Well, this is, instead of just telling you that the law, what I do is x to the fourth. You break that down, that's x times x times x times x. There's 4 x's. That's what x to the fourth is 4x multiplied together. We have a multiplication in between, bring that down. X squared means x times x. That's what x squared means. Well, if you look at this, how many x's do you have multiplied together? Well, that's 6. So there's your answer. X to the fourth times x squared is x to the sixth. Now, if we take a look at what we got going on here, what do we have to do to these exponents to get 6? Well, now we know our rule. We have like bases with multiplication, we add exponents. So the mathematical rule is adding with multiplying like bases is you add the exponents. So let's take that to number 2. So we have like bases, the y's. We are multiplying, so we're going to have to add those exponents. So that's 9 plus 4. Well, now, what else do we have to do? We have our coefficients. Coefficients, you just multiply those together. So 2 times 3 is 6. 9 plus 4 is 13. So you get 6y to the 13th. Number 3. So now let's take what we just did there. We have coefficients, multiplication. We're multiplying 2 different terms, by the way, on this case. Multiplying 2 terms. And multiply your coefficients, so that's 6 times negative 2. I'm just going to rearrange everything. We have x to the third and x to the 0. We have y to the 9th times y squared. Well, what do we do with this? Well, 6 times negative 2 are coefficients. We multiply those together. It's negative 12. We have like bases on our x's with multiplication. So we're going to add these exponents. So 3 plus 0. Again, on the y's, we have the exact same thing. We have y to the 9th, y to the 2nd, multiplication. That's going to be y to the 9 plus 2. So negative 12. 3 plus 0 is 3. 9 plus 2 is 11. So negative 2, x to the third, y to the 11th. Number 4. Here we have a monomial, one term, times 2 terms, times a binomial. Terms are joined by additions or subtractions. So you just got to kind of see that there's no addition or subtraction here, so that's one term. And here you have a subtraction in the middle, so that means that is 2 terms. And the reason why I'm bringing this up is we need to multiply. I'm going to erase that up top now. So we have 1 term and 2 terms. When you have parentheses here, what's on the outside means you need to multiply. So this is distributing, so we're distributing here. So we have 3x squared y. That means 3 times x squared times y. And we're multiplying times 4x to the third y. That's what we multiply the first 2 here. Multiply those 2 terms together. And when we do this, then we have to multiply the next 2 terms. So the 3x squared y needs to get also multiplied times. So 3x squared y times negative 5. I will take that negative, that's a subtraction as a negative with the 5. That helps us with determining what the sign is in between here. So I haven't written a sign there yet. You can write a plus if you'd like. Nothing wrong with that. You can always put an addition in between each term until you figure out when we multiply our coefficients, what's the sign? Is it positive or negative? So I'm going to now break it down. We have the first term, let's put them all together. We have 3 times 4 is 12. The x's, you have x squared and x to the third, that's x to the fifth. Y's, they don't have exponents, but they really do, they're ones. So y1 plus 1 is 2. I'm going to bring that plus down just for now. We have 3 times negative 5 is negative 15. X squared times x to the first is x to the third, like bases add exponents. Y, we have y to the first and y to the second, that's going to be y to the third. Now the only thing we can clean up here, well first, I guess I should stop and slow down a little bit. We have 12 x to the fifth y squareds, 12 of them. And the only way we can put them together with what's over here is if that's x to the fifth y squared, and it's not. They are not the same, so we cannot join these together. There's no way with additions we can join it together. The only thing we can do is this plus and negative. That turns into a subtraction. So this is 12x to the fifth y squared minus 15x to the third y to the third. All right, let's take a look at number 5. So this is a binomial, 2 terms times 2 terms. What I would do is I'd go straight to I call it the Punnett square, the box method. We're going to put x plus 5 on top and x minus 2 on the bottom. It does not matter, you can switch those around, it does not matter one bit. Now we have x times x is x squared, x times 5 is 5x, negative 2 times x is negative 2x, and negative 2 times 5 is negative 10. Now at this point I don't look at anything on the outside of the parentheses. Everything is on the inside is what I'm looking at. So I'm looking at x squared, negative 2x, 5x, and negative 10. Those are my 4 terms. Do I have any like terms? And hopefully you are saying yes. Your like terms are, you have 5x's and we are adding a negative 2x or subtracting 2x. We have 1x squared, that's the top left. So we have one of those, but then we have 5x minus 2x is 3x. We have 3x's left, and then subtracting 10. And there's your final answer there. All right, number 6. Now we're starting something different. Now we have division, not multiplication, but division. So division, you're looking at your coefficients. You're going to simplify those, just like you did back in like 5th grade. You're simplifying 14 over 7. That's 14 actually divided by 7. You can divide numerator by 2 or 7, divide 7 by 7, which is 14 divided by 7 is 2, so that's what you're getting there. So I'm going to start off 2 over 1. I'm just going to keep the 1 there for now. We then have x in the numerator, x to the cubed in the denominator. And this is what I do for that. I actually used to do this all the time in school. We have 1x in the numerator, x to the third means x times x times x. And then what I do is I just simplify out one of the x's, and what's left? Well, there's an x times x, which is x squared in the denominator. So I got to write times x squared in the denominator. So now we can look at our rules. Like bases, when you have division, what do you do to the exponents? How do I get x squared in the denominator? Well, you take x to the third, your biggest exponent, you subtract your smallest, so 3 minus 1 is 2, and you put the answer where the biggest exponent started out. Biggest exponent started out in the denominator, so that's why it's x squared in the denominator. The y squared, there's no y in the numerator, so that just stays y squared in the denominator. We can clean this up a little. We get a 2 in the numerator. 1 times x squared is x squared, and y squared. There's your final answer. So what is the mathematical rule for dividing like bases? You subtract the exponents. So you subtract the exponents. All right, let's continue with that. Oh, and I should say, to subtract the exponents, you simplify the coefficients. So the very first thing we do is we look for the coefficients. Can we simplify them? So 16/12. Can we divide it by something? Well, they're both even, so that's where I always start. If they're both even numbers, I just start there. 16 divides by 2. That'd be 8. 12 does divide by 2, so that'd be 6. Well, 8, 6, that also, they're both even, so that divides by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. We have x to the 5th divided by x squared, so 5 minus 2 is 3, so we put x to the 3rd in the numerator because that's where the biggest exponent was. 5 is bigger than 2. We have y to the 6th over y to the 12th. 12 minus 6 is 6. We're going to put y to the 6th because that's where the bigger exponent was in the denominator. And then z to the 3rd and z to the 0. You got 3 minus 0 is 3. So that's going to say z to the 3rd. There's your final answer. Nothing to simplify. All right, number 8. We have 24 over 12. We can reduce that fraction. You do just divide it by 12, it's 2. So divide by 12, so that's going to be 2. 12 divided by 12 is 1. X to the 7th divided by x to the 7th, so 7 minus 7 is 0. X to the 0 power, I'll write it there for now. We'll just talk a little bit about it in a little bit. And then y 2 minus 2 is also 0. Well, what's anything to the 0 power? Anything to the 0 power is 1. So we have 2 times 1 times 1, because this is 1. X to the 0 power is 1. Y to the 0 power is 1. That's over 1. Well, what's happening here? We get 2 times 1 is 2 over 1. 2 divided by 1 is 2. All right, you probably saw that way earlier. 24 divided by 12 is 2. And then you could cancel out, simplify out your numerators. So then you see it's 2. All right, let's move on to 7.2. So here we're dealing with exponents. We have two different things we're working with. We're working with exponents or powers to powers, exponents to exponents. So raised to another exponent. And we're also going to work with some negative exponents. So let's get started. So when we have an exponent on the outside of parentheses, what we're going to be doing is we're going to distribute. So that negative 4 is raised to the first power. So it's going to be negative 4, 1 times 4. 4 times 7, so it's a to the 7 times 4. B to the 2 times 4. And C to the 1 times 4. So we have negative 4. 1 times 4 is 4. Let me put this in parentheses. It really should be in parentheses because we're going to put that in Desmos. Or you can put it in Desmos. 7 times 4 is 28. 2 times 4 is 8. 1 times 4 is 4. 4 to the 4th, I believe, I don't have a Desmos here, but I believe it's 256. So if it's not, don't yell at me. Make sure you put parentheses around the base. Anything raised to an even power, like 4 or 2 or 6, is always going to be a positive number. There should never be a negative here when it's raised to a positive or an even number. All right, next problem. So now we have a fraction. You're still, when you're raising two exponents to another exponent, like 2 here, you are distributing and multiplying. So it's going to be 1 raised to the 1 over 2, 3 to the 1 over 2. So that exponent 2 is going to get distributed to both the numerator and denominator. It's going to get distributed to the 5, so that's going to be x to the 5 times 2. The y is to the first power, so that's going to get distributed, so it's going to be 1 times 2. And z to the 3 times 2. So 1 times 2 is 2, so it's 1 to the squared. 3 to the 1 times 2 is 3 squared. X 5 times 2 is 10. 1 times 2 is 2. 3 times 2 is 6. Still got a little simplifying I can do here. So 1 squared is 1. That's 1 times 1. 3 squared is 3 times 3 is 9. Be careful with those. That you are raising it to a power. So you know the difference between raising it to a power and multiplication. So that's 1/9. You could multiply up to the numerator, so you could have x to the 10th, y squared, z to the 6th over just 9. That's even more simplified. Kind of combining the two. number 11. We're distributing, so let's distribute. So 3 raised to the 1 times 3. We have x to the 5 times 3, 2 to the 1 times 3, and y to the 4 times 3. 1 times 3 is 3, x to the 15th, 1 times 3 is 3, so that's 2 to the 3rd, y to the 12th. 3 to the 3rd is 27. You can do that on Desmos. 2 to the 3rd is 8. You could look at the 27 over 8 and see if you can reduce that, but you cannot. You can't divide them both by the same number. All right, number 12, so another exponent, power to a power, so we're multiplying, so -2, put in parentheses 1 to the 3. I just put any number in parentheses, the base, and it's never going to be wrong. So like -2, I'm going to put in parentheses and when I put it in, if I put it in Desmos. A to the 3 times 3, so power to power, exponents rules, multiply. B to the 2 times 3, C to the 1 times 3. So -2 to the 3rd, A to the 9th, B to the 6th, C to the 3rd. -2 to the 3rd happens to be -8. There we go. All right, now we're getting into division of negative exponents. So negative exponents, we can so we have negative exponents. Take your base of your exponent, and you're going to move it down. So x to the -10 is going to move to the denominator. X to the -3 is going to move up. X to the 3rd. X to the 10th, y squared. So in math, you can't have a negative exponent as for a base. So that's why I'm moving them. You can still do if you wanted to do the smallest exponent, subtract the biggest, or the biggest exponent, subtract the smallest. You can do that. It's -3 minus -10 is going to be 7, so it'll be x to the 7th in the end. So you could do it that way also, but you cannot have a negative exponent in a finalized answer. So if you ever have a base of an exponent, so the base here is x, and you take the negative exponent, you're going to move it to the other part of the fraction. So at this point, 15 divided by 3 is 5. Divided by 5, you get 3. Divide by 3. My bad. Hopefully you're yelling at me right now. Divide by 3, you get 5. Divide by 3, you get 1. So it's going to be 5 over 1. X to the 3rd divided by x to the 10th is x to the 7th in the denominator. Y squared. Number 14. So we have, my first step is always to move your negative exponents. So y to the -7 is going to go down, z to the -4 is going to go up. So I'm going to copy everything else exactly how it is. So z to the 3rd, z to the 4th, it's all multiplication here. I don't put those little dots, but it's implied that it's there. X to the 8th, y to the 6th, and times y to the 7th. So it's 4x squared. Now we have situation of like bases with multiplication. You are adding the exponents. Remember from 7.1? So we're adding these exponents. That's z to the 7th. And we have x to the 8th. And again, we have the y's. We're like bases with multiplication. You add those exponents. That's going to be y to the 13th. 6 plus 7 is 13. Well, there is something I forgot here, isn't there? You got to simplify their x's. So you have 8 minus 2 is 6. So I'm going to have in the denominator, and 4 6. That can be divided by 2. So that's 2. 6 divided by 2 is 3. So you have x to the 8th divided by x squared is x is 6. 8 minus 2 with division. Like bases, the x's, you subtract the exponents. Put the biggest exponent where put the exponent, the resulting exponent where your exponent is. $15. You have the base of the exponent, and the exponent right now it is not in fraction form, but I'm going to put it over 1 so you can see. We take the base and the exponent, and we're going to move it down. Well, a fraction can't look like this. It's going to be a positive 4. There's nothing in the numerator. Well, what's there? It's always 1. There's always a 1 there. Now we have exponents that we can distribute in. That's going to be 2 to the first. So it's going to be 2 to the 1 times 4. And it's n to the 1 times 4. Distribute that 4 in power to power rule. So that's 2 to the 4th, n to the 4th. 2 to the 4th is 16, so we could simplify that, n to the 4th. And our last problem. You made it this far, good job. In this case, when I have a negative exponent on the outside like this, I would like to distribute first. There are other ways you can go about this, but I'm going to distribute. I think it's a little easier to do it this way. And then we'll worry about the negatives later. So you have b to the negative 4 times negative 2. You have a to the 5th times negative 2. b to the negative 8 times negative 2. So multiply them out to the negative 10, b to the 16th. Now let's look at what we have for negative exponents. So we got to move some stuff. A to the negative 2, a to the negative 10. You don't have to move them. You can do the negative 2 is bigger, so negative 2 minus negative 10 is 8. And so it'd be a to the 8th in the numerator. But I'm just gonna switch them because I think it's a little nicer looking at positive exponents. So a to the 10th goes up. B to the 8th is going to stay there because it's positive. A squared is going to go down and go positive. Now we have our like bases. Subtract those exponents. $16 minus 8 is 8. And there's your final answer. You're more welcome to come with me to Mr. Johnson's classroom. I'm in math planning every Tuesday and Thursday after school. Actually, Monday, Tuesday, Wednesday, Thursday. Most days I'm there. You can stop in by math planning. It's 2518, and I'll gladly help you.